All right, guys, let's take a close look at the first question, which is question 1. So question 1.1 reads as follows. It says solve for x. We are given 3x minus 6 multiplied with x plus 2 is equal to 0. Now we're going to apply what we call the zero factor law. This is a very important law that says if you're multiplying two things and the answer comes out as 0, we don't know which of the two is 0, but one of them has to be 0. That implies that 3x minus 6 is either 0 or x plus 2 is equal to 0. I think if you think about it, the only way you can get a product of 0 is if one of those things that I have is 0. Okay? It doesn't have to be 2. You could have A multiplied with B multiplied with C, and the answer is 0. If that is the case, and we don't know which one, but one of those factors has to be 0. Now, from the first one, if you add 6 on both sides, we're going to get that 3x is equal to 6, and you divide both sides by 3, x comes out as 2. And on the second one, if x plus 2 is equal to 0, then it implies that if you take away 2 on both sides of the equation, you end up with x is equal to negative 2. All right. Now, moving on to 1.1.2, we are asked to solve for x if 2x squared minus 6x plus 1 is equal to 0. Now, this hint that they gave us here tells you that you can't factorize. So unfortunately, we cannot be able to factorize this, so we have to use the quadratic formula, right? So the quadratic formula requires you to have a value of a value of b, and the value of c. Fortunately for us, the quadratic equation is already written in standard form. So what I'm going to do here is copy down the formula, which is negative b plus minus the square root of b squared, take away 4ac, and everything here needs to be divided by 2a. Now, we're going to sub here your a, your b, and your c. Just be mindful of the fact that your a value is positive 2, but your b is negative 6. So that negative is very important. If you do not put that negative in your b value, you're not going to get the correct solution. Now, this has to be added or subtracted with b squared. Now, a lot of you might sub it as negative 6 squared minus 4 multiplied with a and then multiplied with c. But there's going to be a big problem with negative 6 if you do not enclose it in brackets. So it's very important for us to make sure that we always put whatever we are subbing in brackets, okay? Your a value is equal to positive 2. Now from here, all you guys need to do is just to compute this in a calculator and try and figure out what the value of x is going to be. And if you just type this on the calculator, you should end up with an important answer that tells you that x is either going to be equal to 2.82 or x is equal to 0.18, because you have to obviously remember to always round off your answers to 2 decimal places. Okay, moving on to the next one. We still have to solve for x, but this one is an inequality because of the fact that we've got the greater than x symbol in our question. All right. Now we're going to first of all try and write this in standard form. So I'm subtracting x on both sides. So that's going to leave me with x squared minus x minus 90 is greater than 0. All right. Now the quadratic on the left hand side can be factored because we're trying to figure out what we call the critical values of this particular equation or inequality. I think 10 and 9 will give us 90. And they will give us negative 1 when 10 is negative and 9 is positive. So what you're going to have here is what we call the critical values. If I think about it graphically, it means we are basically sitting with a parabola, okay, a happy face parabola or concave up parabola. That's what you're looking at right now. And on the left hand side, it should cut x at a number that we would call the critical value of this inequality, which is x equals to 10, and another critical value is x is equal to 9. We refer to these as critical values because this is where the function changes from being positive to being negative. So the number here on the left hand side is obviously negative 9. That's the one that you have here, and the one on the right hand side will obviously be equal to 10. Now what are we looking for? We are interested in finding the values where this graph is greater than 0. Now greater than 0 implies that it is positive. So if I was to put signs on my graph and I'm looking at it from the left hand side to the right hand side, I think you'll agree with me that above the x-axis the graph has to be positive. That means the graph is positive. Remember, the graph is y, and the y values of the graph will be plus for as long as the graph is above the x-axis. And then below that, the graph is going to be negative, okay? It's going to be negative here because the y values that correspond to this part are going to obviously be negative. I don't care where the y-axis is, but no matter where you draw it, below the x-axis, the y values are negative, and above the x-axis, y values are positive. Now, the question is asking us to find all the x values that will make that particular graph to be greater than 0. So by looking at this part here, which is implying that we want to know where is the graph positive, okay? We want it where it is above the x-axis. So that implies that the solution will definitely have to be all the axes before negative 9, okay? All the axes on the left of negative 9, the graph is above the x-axis, and all the values after 10, the graph is also positive. So it's all these x values here that will make our graph to be positive, and also all the x values after 10 will also make our graph to be positive. So we're basically looking at those parts there. That's why sometimes you'll see us writing a plus here to imply that the graph is positive on the left of 9, negative 9, and the graph is also positive on the right hand side of 10. So the solution to that question will then simply be all x values that are less than negative 9, or all the x values that are bigger than 10, they will make the graph to be greater than 0. Right. Moving right along, our next question, 1.1.4, is one that involves surds. So every time when you've got this kind of a question, what you need to do is always isolate the surd, okay? So I'm going to try and isolate this. That's actually the way you approach this question. If you are dealing with exponential equations, you need to make sure that your surd is left on its own on its side, okay? So you isolate this, and this is true for surds, and it's also true for exponents, okay? When you're dealing with surds or you're dealing with exponential equations, always make sure exponential equations, always make sure that you isolate that particular term, that is the exponent or the surd. Now I'm going to add the 7 root x on both sides of the equation. When I do that, it's going to leave me with x on the left hand side. If I add 7 root x on the one side and also add 7 root x on the other side, okay, the 7 root x on the left hand side will disappear, and I'll just be left with negative 12 plus 7 root x. Now after that, I don't want the negative 12. I'm just going to add 12 on both sides of the equation. That is going to leave me with x plus 12 is equal to 7 root x. Now once I have this, I'm just trying to figure out what x is going to be. So I don't like the surd, so I'm going to square on both sides to try and get rid of that particular square root. So when I square on the right hand side, I also need to do the same thing on the left hand side to balance my equation. Now the left hand side binomial squares to x squared, plus you multiply 12 and x, you get 12x, and you have to double the result. It will give you 24x, and then we have to square 12, we're going to get 144. Then on the right hand side, if you square 7, you're going to get 49, and if you square the square root of x, you're going to just get x. Now I know sometimes we have problems with squaring binomials, so there is no shame in taking this and expanding it to x plus 12 and multiplying it with x plus 12 and going the long route, applying what people normally call foiling or the distributive law. In this case, you will end up with the answer x squared plus 24x plus 144 is equal to 49x. And then, of course, on the right hand side, when you square, you do not only square the square root, you must also square the x, okay? So, I mean the 7. So you square the 7, you're going to get 49. And then you also square the square root of x. That's where x is going to come as our solution. Okay, cool. Now, I'm going to just make sure that all these terms are on the left-hand side. So I'm going to subtract 49 on both sides of the equation so that I'm just left with 0 on the right-hand side. And then proceed to factorize and see how far I'm going to be able to get with this awesome question. Okay, so I think you guys will agree with me that when we subtract 49 on both sides of the equation, you will have 24 minus 49, and 24 minus 49 will give us whatever the x term has to be, and it obviously has to be negative 25, all right? So I'm going to have negative 25x's. I'm adding 144, and the answer should be 0. Now I need to factorize this quadratic on the left-hand side. What do I end up with? The factors of x squared is x and x. I'm looking for two numbers that will multiply to 144 and add or subtract to 25. It turns out that when you take 9 and 16, okay, 16 plus 9 will give us 25, and then 16 times 9 is going to give you the number 144. That implies that x is either going to be 16 or x is equal to 9. Now, when you're dealing with inequalities, you need to do something important, because this is not the end of it, okay? You need to just ask yourself, is this done, or is something else need to be done here, okay? So it turns out that you need to try and check if both answers satisfy the equation or not. Now, when I'm checking, I'm going to check here for validity. Is 16 a valid solution to the question? You check it by subbing it back to the question that was given to you. That x minus 7 root x equals to negative 12, okay? So I'm going to check if that answer works or not. So x minus 7 square root x equals to negative 12 is what I was given. So I'm going to sub 16 there. So is 16 minus 7 times the square root of 16 equal to negative 12 or not? I think you'll agree with me that the square root of 16 is 4. So I'm actually sitting with 16 minus 7 times 4. And 16 minus 7 times 4 will give you the value which happens to be negative 12 on the left-hand side. So negative 12 is equal to negative 12. So that means that the answer 16 is actually valid. So I'm happy with this. This actually works. Now I'm going to check if 9 also works. Okay, let's check if 9 is also going to work. The equation is x minus 7 root x equals to negative 12. I'm going to sub 9. Is 9 minus 7 times the square root of 9 equal to negative 12 or not? Now 9 is 9. The square root of 9 happens to be 3, okay? And if you check on the left-hand side, 7 times 3, if you do 9 minus 7 times 3. So 9 minus 7 times 3 does in fact give you the answer negative 12. So yes, negative 12 is equal to negative 12. So it turns out that both these answers are valid. I've checked them. Always remember, every time when you're doing questions with surds, you need to go back and check if your answer is valid or not. Just answering and leaving it there is not enough. You must go back and check if both these solutions satisfy the equation or not. Okay, it turns out in our case, both of them are valid, so we're pretty much happy because it turns out that they both satisfy the equation. Now the next question is question 1.2 quickly. This one is asking us to solve for x and y simultaneously. All right. Now, in order to solve for x and y simultaneously, of course, we've got two equations. I'm going to name them equation 1, and I'm going to name the second one equation 2. So I'm going to start with equation 1, the first one here. And I want to make either x or y the subject of the formula. So if 2x take away y is equal to 2, I'm sure you'll agree with me, it will be better to make y the subject of the formula. So if I add y on both sides of the equation, I'll have y on the right-hand side, and I subtract 2 on both sides of the equation, I'm going to have 2x take away 2. And this I'm going to name equation 3. Now I'm going to then take that equation 3 and sub this into equation 2, the one I have not used yet. That means since I was given x multiplied with y as 4, wherever I see y, I'm going to replace it with the expression 2x minus 2. So I'm going to take this and just plug it here wherever I see y, which means I'm now going to have x multiplied with 2x take away 2 is equal to 4, right? Now, if you simplify that, you then end up with something awesome, which is going to be 2x squared minus 2x equals 4, and then 2x squared, take away 2x, subtracting 4 on both sides of the equation, we get negative 4 is 0. Dividing every term by 2 on both sides, you end up with x squared minus x minus 2 is 0. We then have to factorize this. We get x minus 2 and x minus 1. Obviously, we need to get a sum or a difference that leads to negative 1. This one has to be positive 1. And then I'm sure you'll agree with me that x is going to definitely be either 2 or x is going to be negative 1. Now, I need the corresponding y values for those x's. So what you simply do is you take them and you plug them back into equation 3, which is this equation that we have here. So I'm going to use that equation to try and see what y is going to be. So y becomes 2 times 2 minus 2. I have 4 minus 2, which gives us a y value of 2. Or the other y value is what you get when you substitute negative 1. Okay, so it's going to be the following. It's going to be 2 times negative 1, and obviously we have to subtract 2 because we are obviously subbing into equation 3, and then this gives us negative 2 times 2 times negative 1, which is negative 2 minus 2. I'm ending up with an answer that happens to be equal to negative 4 for that coordinate. So when x is 2, y is going to be 2, or when x is negative 1, y is going to be negative 4. So this is how you do a simultaneous equation question. All right. Moving on to question 1.3. Now, in question 1.3, they're asking us to show that 2 multiplied by 5 to the power of n minus 5 to the power of n plus 1 plus 5 to the power of n plus 2 is even for all positive integers of n. Now, we have to talk about what makes something even. What makes something even is if it is multiplied by the number 2 or a multiple of the number 2. Now, if you think about it, if I give you a random number, let's just say I give you the number k. So k can be anything. We don't know if k is even or odd. But I promise you, once I start introducing a 2 here, it will definitely make this to be even. There's no two ways about it. The fact that you're multiplying it by 2 definitely makes it to be even. Now, if this is even, it doesn't matter what it is. If it's a 5, 2 times 5 becomes 10, and 10 is even. If k is, for example, let's just say 3. 2 times 3 is 6, which becomes even. If the k is, let's say, 20, 2 times 20 becomes 40, which is also even. So the 2 definitely forces the whole thing to become even. Now, what makes something odd? What makes something odd is if you have an even number and you add anything odd, it's going to make the whole thing to be an odd number, okay? So we just have to try and prove that what we are looking at is a factor of 2. To some extent, not a factor, but is a multiple of 2, okay? Whatever this is, we need to show that this is going to look like this to some extent, right? Now, let's look into it closer. So 2 times 5 to the n is 2 times 5 to the n minus. I'm going to expand that to 5 to the n multiplied by 5 to the 1. I'm applying laws of exponent here to separate that to 5 to the n and 5 to the 1. And then I'm going to obviously have 5 to the n times 5 to the 2 for the second one. Okay, this is actually very important. You're just splitting them because I'm trying to factorize. If you're dealing with exponents and you see pluses and minuses in your expression, I always think factorization. Because of this and because of that, I'm always thinking I need to factorize somehow. This leads to an idea of factorization. So you always do that. When you're dealing with exponents and you see pluses and minuses in your brain, always try and think about how factorization can help you to figure out the solution. So I had to break this to 5 to the n and 5 to the 1, and break this one here to 5 to the n and 5 to the 2 because I'm looking for the common factor. I think you'll agree with me that when you look at these, 5 to the n is common, okay? I'm just going to put that in boxes. Let's just say we've got the first box, and I've got a second box here, and I've got the third box here. So in all those boxes, you'll agree with me that we do have 5 to the n, so I'm going to take that out as a common factor, right? Now it leaves me 2 on the first box, it leaves me with a 5 in the second box, and it leaves me with 5 squared in the third box. Now this then becomes 5 to the n multiplied by, I don't know if you will agree with me, but 5 squared is 25. If you add 2 on 25, you get 27, and if you subtract 5 from 27, it takes you straight to 22. So I'm going to be left with 22 here, okay? Now, I don't know if you see this, but 22 is a multiple of 2. So that implies that it definitely looks like what we were looking for. Remember, we are looking for something that looks like this. So I can confidently say that right there, 22 times 5 to the n will always be even no matter what, okay? If I start with 22 and I have 5 to the n inside the bracket, we can even go to a point of saying, okay, because I'm multiplying it by even, it has to be even. There's no two ways about it. If you want to see the 2, I can say this is 2 times 11, okay, times 5 to the n. The fact that I've got a 2 there, it's definitely going to make it even, because 2 times anything will always be even, okay? I can even do this for you guys to see that actually it is definitely going to be even because of that number 2 that lies outside the bracket. So it doesn't really have to be 2. It has to be a multiple of 2 that will definitely make whatever you're looking at to be even. So this is me just forcing it to be 2 times something for you guys to see. Okay, cool. Now in closing, 1.4, we're looking at 1.4 now. It says we need to determine the values of x and y if 3 to the power y plus 1 over 32 is equal to the square root of 96 to the power of x. Now, when you're dealing with surds, like we have discussed already, okay, the first thing that you need to try and do is to get rid of the surd. So I'm given the square root of 96 to the power of x. I don't like having that. So I'm going to square to undo the square root. But if you do that on the right hand side, we definitely need you to repeat the same on the left hand side. We need you to maintain the same energy on the left hand side as well. Now, if you're squaring, I don't know if you remember this law, but we are applying the law that says if you have a over b and you're raising it to the power of some exponent n, you have to raise a to n and also raise b to the power of n. It's laws of exponents. We've learned these, and I'm going to start using that particular law in this particular case on the left hand side. So when I raise 3 to the y plus 1 and square that to the power of 2, I'm going to get 3 to the power of 2y plus 2. Divided by, when I'm raising 32 to the power of 2, I'm going to get 32 to the power of 2. Okay, so what I did, I just simply raise that to the power of 2 and then also share the exponents to 32 as well. Okay, now 32 can be simplified further and expressed with a prime base, but before we do that, on the right hand side, the square and the square root will cancel each other, which is the very same reason why we actually did the squaring in the first place. It was to get rid of that particular square root. Okay, now on the left hand side, what I'm looking at is 3 to the power 2y, which I'm going to write as 3 to the power 2y. I'm adding that with 2. Now on the denominator, the 32 can be expressed as 2 to the power of 5. But then remember, we still have the 2 that is outside, and the 5 and the 2, when they communicate, they will give you a 10, because when you're raising a power to an exponent, it's going to actually multiply the exponent. So I'm going to be left with 2 to the power of 10. Now, on the right-hand side, I've got 96, and I'm going to prime factorize 96, and 96 as prime factors. If you know how to work out prime factors, you're just going to have to change it to 2 to the power of 5 multiplied by 3. But remember, we still have the x that is lying outside. Again, we are faced with a situation of raising a power to a power, so I'm just going to have to simplify by distributing the exponent on the right hand side. So I've got 2y plus 2 divided by 2 to the 10 equals to 2 to the 5 times, okay, wait, let's just do it now. Let's just do that already now. This is the right time. I'm going to distribute this, okay? I'm raising 2 to the 5 to x. I'm also raising 3 to the power of x. So 2 to the 5 is going to be 5x when you multiply with x, and then 3 to the 1 raised to x is going to become 3 to the power of x. On the left hand side, I'm going to apply laws of exponents that say if you have something, let's just say you had a over b to the power of n, you can literally rewrite this as a times b to the power of negative n. Notice that the n changes sign from positive to negative. So I'm going to apply that on this particular denominator here because I don't like the fact that my 2 is on the denominator. So I'm going to have 3 to the power 2y plus 2. Now the 2 becomes 2 to the power of negative 10. It's going to be 2 to the 5x multiplied by 3 to the power of x. Now when you are here, you apply something that is called the concept of equality. Okay, 3 times something, 3 to the power of something times 2 to the power of something else equals to 3 to the power of something times 2 to the power of something else. So by just looking at the 3's, okay, if I look at the 3's, the exponents have to be equal. So I think you'll agree with me that the only way this is going to be true is if 2y plus 2 is equal to x, equating those exponents that we have for base 3. Now, base 2 has to behave the same as well. So if you look at those bases, they are equal. So the only way this will be true is if negative 10 is equal to 5x. And from the blue equation, we can literally say, oh, well, x has to be negative 2. And then we can sub it on the left-hand side to figure out what x is going to be. I think you'll agree with me that we are looking at 2y, okay? Let's just maintain the consistency of color there. I will have 2y plus 2 is equal to x, which we found to be equal to negative 2. Now, I think if you try and solve for that, you get the fact that 2y is going to be equal to negative 4 when you take away 2 on both sides, and that leads us to a y value of negative 2 when we divide both sides by 2. So both x and y are equal, and they're both equal to negative 2. Okay, this is how you analyze algebra, which happens to be question 1.